Hello guys, welcome to Nibble Gurukul. My vision is to give a free quality education to all. With this vision, I spend my energy, my sources. I need one help from you all. If you like these videos, kindly subscribe the channel and share with your friends and also like it. I would be grateful to you. So let's learn today logical operators. What are the logical operators? And or. These are the two logical operators we have. These two are binary operators. We also have a one more is called not, which is a unary. Okay. So how to use it? What is binary? What is unary? I will study. What is binary? It needs two operands. What is unary? It needs only one operand. Okay. Let's say right now in this case, my x value is right now in this place is 7 and y is 3. Okay. The logical operators, like relational operator, will produce for you 1 or 0. It needs two operands. One is on the left hand side, other one is on the right hand side. So I'm going to write like this. Left hand side, I'm going to write x is greater than y and y is less than 10. That's what I've written. Okay, these are two expressions. In these expressions, you have a logical and relational. What I should solve first? Okay, first we'll solve the relational. Okay. When I solve the relational, x is greater than y. What I get? What? 1. If the left hand side is 1, if the left hand side is non-zero, it is going to solve the right hand side. Remember, it's going to solve the right hand side. So y is less than 10. What I'm going to get what is 1. 1 and 1 is 1. It's going to give me what? 1. That means in both the side, if there is non-zero value is there, it is going to produce 1. It's going to produce what? 1. Now, if the left hand side is 1, but the right hand side is 0, it produces, the answer is 0. If the left hand side is 0, it will never go and solve the right hand side. It will directly produce what? 0 to you. Okay? Therefore, the logical AND requires both the sides non-zero. In this case, the result is 1. Why I stress the word non-zero? If I write it in this case x and y, the answer is what? 1. Both the sides are non-zero. What does the OR will do? What does the OR will do? The OR require any one of the side non-zero. I have written like this: x is greater than y or y is less than 10. So x is greater than y is 1. Oh, if this left hand side is 1, it will never solve the right hand side. It will directly produce 1. Never solve it. It will directly produce what? 1. That means the right hand side of this operator, remember, right hand side of this operator will not be solved. Okay, and will produce 1. The logical OR operator require any one of the side what? Non-zero. If the left hand side is non-zero, it will never solve the right hand side. It will directly produce what? 1. If the left hand side is 0 and the right hand side is 1 and the result is what? 1. If both the sides are 0, the result is what? 0. Okay. Now, then let us see here what is the NOT operator is going to do. The NOT operator. The NOT operator will convert the non-zero to 0 and 0 to 1. What do I mean by this? Non-zero to 0. I have written like this: x is greater than y is 1. NOT will make it as what? 0. X is, if I write like this, x is less than y is going to give me 0. If I put NOT before, I'll get what? 1. Okay, if I say x is 7, if I put NOT before, I am going to get what? 0. If I say here x is 7 and if I put here right now NOT and then NOT, if I put, what is going to happen? I get 1. Why? Because 7 NOT is 0, 0 NOT is what? 1. Okay, so this is the basic structure of this. Okay, so let us see. I have said this: the logical and does not solve the right hand side if the left hand side is 0. The logical or does not solve the right hand side if the left hand side is what, 1 or non-zero, right? Okay, so let us solve some more expressions. So how I it will work for me. So we let us solve this expression. Okay, x is less than y and y is less than 10 or y is greater than 3. Whereas my x is right now 7, y is right now what, 3. Okay, I saw like this: x is less than y. Its one's answer is what, 0. Oh, left hand side is 0. Will it not solve the whole right hand side? No, 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 no. If the left hand side is 0, therefore what is going to do? The right hand side of this will not be solved. The answer for this expression is 0. Since the left hand side of r is 0, it is going to solve the right hand side. Y is greater than 3. What I am going to get, what? It's 0. 0, and this is what is going to be 0, or 0 is what? 0. Whereas if I could have put right now in this place y is greater than 2, what would have happened? 3 is greater than 2, what would have happened? 1, 0 or 1. What I could have got, what? 1. Okay? Remember that. Now, if I say right now, in this example I have written here, I also use a not. Okay, what is going to happen? X is less than y, and I put this in a bracket and I put a not, and y is less than 10 or y is greater than 3. If I write the same thing, what will happen? X is less than y. What I am going to get? I am going to get right now 0. Not will make it as 1. The left hand side is 1. Therefore, right hand side is going to be solved. Y is less than 10 is 1. 1 and 1 is what? 1. Since the left hand side of r is 1, the right hand side will not be solved. The answer is what? 1. Answer is what? 1. Okay. Let us solve a simple problem. Okay, so I want to say right now, I have been given a character. I want to check whether the character is a lowercase or not. Okay, I have been given an input character. Okay, and I need to check whether the character is what, lowercase or not. So when I say character, I am going to enter a character, right? When I enter a character, if I use a input is what, percentage C, what is going to happen? Whatever the character, single character I enter, and what is going to be stored inside the ASCII value. Okay. For example, if I entered A will not be stored. What will be stored? 65. But if I enter small a, what will be stored, what? 97. If I enter small z, what will be stored, what? 122. Now what is my question is, I need to find out whether the given character is lowercase or not. What do you mean by lowercase? It lies between 97 and 122. Between 97 and what? 122. We remember last class I taught a relational operator. In that, mathematically we could have written like this: if you are given character ch is less than or equal to what, greater than or equal to 97 and less than or equal to 122, this is a mathematical expression which we can't write. We said why we can't write, because we said this will be done first, the result will be stored in a register. That register value will be stored with what? 122. This is what we said last class. This can be 1 or 0, right? Therefore, this is not the way to compare. In this case, how do I know a character lies within the range of lowercase a to lowercase what z? That means the given character ASCII value must lie between 97 and 122. How do I write it? If ch is my variable, and that should be greater than what? Greater than or equal to 97, and it also should be what? Less than. Both the conditions should be there. It should be greater than 97 and it also should be what? Less than 122. Therefore I put and ch should be less than or equal to 122. This is the way I'll write. If I put or, any one of the condition needs to be satisfied, because it has to be between, both the condition needs to be satisfied. Therefore I will write what in this case? And. Okay. Now, let us see here in this case is I want to say whether the given character, is a vowel or not. Okay, is a vowel or not. This is what I want to write it. So, how do I write it? I want to say whether the given character is vowel or. So how do I check it? I'm going to say here that means it can be vowel. What the vowel? What it can be A, E, I, O, U. Remember, it can be either in uppercase or what? Lowercase. Okay, let's deal right now with one case. Okay, I'm assuming in lowercase. Now, in this case, what I can do? It can be either A or E or I or O or U. Right now, in this case, how do I write? CH can be equal to A. A means when I enter A, I don't store A. What I store? ASCII value. But I can't remember everything ASCII value. The first simple thing. What you put what? Single quote A. Or either this has to be true or CH is equal to what? E. Some people ask a question to me, sir, why don't you put a E directly? Oh no, if you put E directly on the right hand side of R, you put a non-zero, it will directly give you 1. Directly give you what? 1. So you need to compare the ASCII value with this ASCII value. Or CH is equal to what? I. Or CH is equal to what? O. Or CH is equal to what? U. Because any one of the condition needs to be what? Satisfied. Okay. Let's write a program. Okay. So I am going to input a character. Right. And my variable name is CH. I want to say whether the given character is lowercase or not. Okay. Whether the given character is vowel or not. Whether the given character is what? Is a vowel or not. So in this case, I am going to put scanf and percentage what? C, comma and CH. Now, as I told you, when I enter a character, single character, I don't enter the character. The corresponding ASCII value is stored. Therefore, what I am going to say, if CH is equal to A, or I already told you I can't put a E in a single quote directly. Why? Because if you put E in a single quote, right hand side of R is non-zero, it will directly give you what? True. Okay, therefore I put CH is equal to E, or CH is equal to what? I, or CH is equal to O, or CH is equal to U. Done. In this case, printf. If I have one statement, wow. Else, I'll say printf, not a vowel. Correct? Correct? Okay. But sir, I'm going to enter right now. I enter a character. I entered right now. Okay, remember I entered right now A, and it gave me vowel. I entered right now. I am going to write right now in this case X. It is going to say not a vowel. I am going to enter right now in this place. I am going to say here. Let's say in this case here capital E. It is going to say it is not a vowel. It is not a vowel, but says a vowel, right? So in this case, what I need to do, because the ASCII, you have compared here only the ASCII values of lowercase, but you not compare the uppercase. Therefore, what you do, you have one option. You can put in another 5 more comparison. CH is equal to this. Otherwise, what you do, convert the uppercase to lowercase. How will convert? The ASCII value of uppercase 65, A 65, small a is what? 97. Uppercase B is what? 66, and this is what? 98. Therefore, the difference is always what? 32. Therefore, if you want to convert the uppercase to a lowercase, what you do in this case here? Add what? 32 to it. It will become what? Lowercase. Okay. So let us modify our program. So what we are going to do? We are supposed to say, with a given input, add what? 32. I'm going to run the code. Yeah, I solved my problem. I enter capital E. I got the answer. I entered right now. I'm going to enter here capital U. I got the answer. But I'm going to enter small e. I'm in trouble. Why? Because with the ASCII value of small e, which is 101, you added 32. This does not match with anybody. It adds with what? Anybody. That means this statement needs to be selected with the condition. What is the condition need to apply? If my CH should be what? It should be between the range of uppercase A to what? To the uppercase Z, right? How to write it? Between. That means it has to be greater than the ASCII value of capital A. It should be less than what? This. Therefore, what I write it? If CH should be greater than or equal to capital A, when I put capital A in a single quote, I am not putting capital A. I put the ASCII value of capital A, which is 65, and CH is what? Less than or equal to capital Z. In this case, only one statement. I don't need a brace. If you want, put a brace. Put a brace. In this case, only I will add 32. Otherwise, I am not going to add what? 32. Okay, let's see. Now I am going, enter capital A. I got it's a vowel. I enter small a. I got it's a vowel. Okay. Now, instead of writing Z, can I write here in this place 90? Yeah, I can write. Doesn't matter for me. Okay. I am going the same output. If I give you, I put capital E. I put here right now. It's a vowel. It comes one. Okay. But you don't need to remember this. If you want to remember. If you don't want to remember, put what the little this. But where I am going to face a problem now, I am going to say right now, I am going to enter in this example, I am going to put here 9. What is saying? It's saying it's not a vowel. First of all, it is not an alphabet. How do I say it's not a vowel here? Therefore, what I am going to do? That means when I need to use this if, only if the given character is what? It is an alphabet. Otherwise, I am not supposed to use. Therefore, again, this whole if now, I am going to put inside an if. If CH is greater than or equal to small a and CH is what? Less than or equal to what? Small z, then I am going to use this. Instead of not a vowel, you can also say it is a consonant. Right? Now, if not what? See, this is I am putting in another else here. Okay, I am putting in another else for you. This else is part of this if, which is going to say the given character, printf, the given character is not an alphabet. So you might ask a question, sir, why you did not write uppercase here? No, I don't need to write this. Why? Because if your uppercase is given, you convert into lowercase, then only come to the next statement. Okay? Therefore, I did not give this. Let's say I put 9 is saying not an alphabet. If I put here E, it is saying it is an vowel. X, it is saying it is not it's a consonant. Yeah, make a note of it. You solve by yourself this, okay, and see where you are making mistake. Come and verify the code. Okay, that will help you to what? Understand. Don't just only listen. Okay, just see, go, type it, execute the same program by yourself, make a mistake and correct it and come. So let's solve another problem, okay, that will help us to understand how to apply the logical operators, okay, and relational operator both combined. Let us solve a problem, okay. So the problem is the input is going to be year, the output is going to be whether the year is a leap year or not a leap year, okay. Remember my output, input, process and the output. This is my input. This has to be either leap year or not a leap year. Okay. Now let us talk about the process. What is a leap year? We all will say any year that is divisible by. Divisible by means what? The remainder needs to be what? 0. When I divide by 4. When I divide by 4, the remainder needs to be what? 0. If the given year modulus, if this result is 0, that means I want to compare with what? 0. It's a leap year. This is what we say, right? But it is not true. This condition is not always what? True. It is true some extent, but to some extent it is not true. Okay? When it is not true. Let us see here in this cases, I am going to give an year. The year is 2000. Yeah, it is divisible by 4 and we know it's a leap year. 2004. It's a leap year. 2024 is a leap year. But what about 2023? It's not a leap year. Why? Because not divisible by 4. That challenge is coming here right now with the 1900. When 1900 is divisible by 4 but is not a leap year. 1800 is divisible by 4. It's not a leap year. Okay, sir. So then why? Why? Okay. The problem is here is a given year is a leap year not only by checking with 4. Okay, there is another criteria is also available. What is that? Before we go to this, let me ask a question to you. A year has how many days? We all will say 365 or 360. No, a year has 365.24 days. What we do, 365.24, 365.24 and 365.24, when I add it on the fourth year, what we do, the 0.24 we add it and make it 366. But the challenge here, when you add 0.24 4 times, it is not 1, it is 0.96. We are running shortage of 0.04. Therefore, what they have done, every year that divisible by 4 is a leap year, except the year that is divisible by 100. Except the divisible by 100. That means any year that divisible by 100 is not a leap year, and they are given exception. But if the year is divisible by 400, yes, it is a leap year. If it is divisible by 400, that means if you want to see any year that is divisible by 100, you want to make it as a leap year, the condition is that year must be divisible by 400. If the year is not divisible by 100, it should be divisible by 4. Okay, so I am going to write the condition, I am going to put in a text form, and you convert into a code form and compile the code and come, and then we will solve the problem. So what is the condition? This is a condition. Year divisible by 100 must be divisible by 400. Year not divisible by 100 must be divisible by 4. Otherwise is not a leap year. Okay, now what you do is go write the condition, compile your code and run and see. You give the input 2000, I should get the output what? Leap year. If I give you 2004, it should give me leap year. If I give you 2024, it should give me leap year. If I give you 2025, it should say not a leap year. Okay, and if I give you 1900, it should say not a leap year. Okay, so let us solve the problem. What is my input? My input is going to be the year. What is the output I should get? I should say either the given year is a leap year, percentage D is a leap year, or not a leap year. or I should say percentage it is not a leap year. Okay, percentage it is not a leap year. So that means I need either I have to say this or this. Therefore, I am going to put an if. I'm going to put an else. What is the condition is what? If input printf enter the scanf percentage t and what here. Okay, now what I'm supposed to do, I am supposed to put a condition here. I need to give either true or false, right? Now what we said, if the year divisible by 100, how to write it? Divisible by 100, the remainder must be what? 0. The expression should produce 0. If divisible by 100 must be divisible by 400. How to write it? Must be, that means and here modulus 400 must be also 0. Otherwise, how to write otherwise? Or if the year is divisible by 4, that means when I divide this by 4, the remainder must be what? 0. That means in this expression, I have arithmetic and relational. What will be solved first? What? And arithmetic. Okay, arithmetic will be solved. If the year divisible by 4, it should not be divisible by 100. It should not be. How to write it? Should not be. Here, modulus 100 is not equal to 0. Must not be what? That means if I enter right now 2004, how it works? 2004 modulus 100, how much I get what? 2004 modulus 100 is 4. 4 is equal to 0. Condition becomes what? False. False means I get 0. Left hand side of AND is 0. Therefore, it is going to skip the right hand side of AND. Left hand side of OR is 0. Therefore, it's going to the right hand side. Here, modulus 4. 2004 modulus 4 is 0. 0 is equal to 0. Condition is true. You get 1. Left hand side of AND is 1. Therefore, it's going to solve the right hand side. 2004 modulus 100 is how much it is what? It is 4. 4 is not equal to 0. Therefore, condition is true. Therefore, I get the 1. 0 or 1 is 1. I get as a leap year. 2004, I got it. I get 2000. Yes, I got it. I get 1900. It's not a leap year. If I get it right now, 2023, so it's not a leap year. Okay. Yeah, but in this whole expression, one condition is not required. Which one? This condition is not required. Why? Because if a year is divisible by 400, obviously it will be divisible by 100. Therefore, this can be knocked out. This can be what? Knocked out. Thank you for listening, and I am giving some problems below in the link. Solve the exercise, okay, so that you understand what you have learned today, and you can check yourself, okay. Ensure that the link is given below, and if you have not subscribed, kindly subscribe and kindly share with your friends. Thank you.